Hello, everyone. Imagine you are holding a shiny, flexible, and strong copper wire in your hand. But do you know where the journey to create this wire begins? It could have been part of an old air conditioner, a broken motor, or even the electrical cables in your home. Copper is not only a precious metal, it is also an indispensable part of our modern life. And the most special thing, copper can be recycled infinitely without losing quality. In today's video, we will explore the magical journey from lifeless scrap copper to brand new copper wire, ready to serve modern constructions and equipment. Scrap collection is the first step in a seemingly simple process that serves as the foundation for the entire production chain. Did you know that millions of tons of electronic equipment and machinery are discarded globally every year, and a significant portion of that waste contains valuable copper treasures? Uneven electrical cables and electrical equipment are a rich source of copper. According to statistics, global e-waste is expected to reach 74 million tons by 2030, of which cables and wires account for a significant portion. These figures not only show the potential amount of copper that can be recycled, but also highlight the importance of properly disposing of these materials. Scrap copper collection occurs at many levels, from households and small businesses to large-scale e-waste processing centers. Collection centers not only collect materials but also conduct preliminary sorting to ensure the highest efficiency when entering the recycling process. Bundles of old cables, heavy motors, or even small pieces of debris have the opportunity to become part of a new life. Once collected, scrap copper is brought to the plant to begin the sorting process. This is an extremely important step because it determines the quality of the copper after recycling. Copper can exist in many different forms and needs to be carefully classified. Pure copper, also known as red copper. This is the purest type of copper, the best conductor of electricity, and is often found in electrical cables and electronic equipment. Copper alloys, including brass-zinc alloy, bronze, and copper-nickel. These alloys are often used in the production of household and industrial equipment. Copper scrap, small, scrap pieces of copper from the manufacturing process or dismantling of equipment. Once sorted, scrap copper is cleaned to remove any remaining impurities. This is an important step to ensure the best quality of recycled copper. For electrical wires, modern wire stripping machines such as SuperStrip will remove the plastic insulation without reducing the weight or quality of the copper. Compared to the traditional burning method, this method is not only safer, but also more environmentally friendly. For electric motors contain copper coils wrapped in iron cores. The cleaning process begins with the disassembly of mechanical parts using a specialized cutting machine. The copper coils are then separated using a core separator or manually, which completely removes the surrounding iron without damaging the copper wire. For air conditioner radiators often have copper tubes nested in aluminum. A specialized metal separator presses and separates these metal layers. This process ensures that the maximum copper is recovered without any impurities from the aluminum. Modern recycling plants also use dry separators such as dry separators to separate copper and aluminum from PVC or rubber. The wire is fed into the shredder, and the mixture of plastic and copper is passed through a pneumatic separator. A strong air stream blows the lighter plastic or rubber coating off the copper, while the heavier copper wire falls to the bottom. Once the copper has been thoroughly cleaned, it is fed into a furnace that heats up to around 1085 degrees Celsius, the melting point of pure copper. But don't think it's just a simple process of heating up the metal. There's an art and science behind these furnaces to ensure the recycled copper is of the highest quality. The smelting process begins with furnace preparation. Factories use modern induction furnaces or electric arc furnaces to precisely control the temperature. Induction furnaces are preferred because they heat up quickly and evenly, saving energy and minimizing heat loss. Copper ingots and scrap are fed into the furnace via an automated conveyor system, ensuring safety and efficiency. As the furnace reaches the required temperature, the copper begins to change from a solid to a liquid state. At this stage, the difference in density between the copper and other impurities becomes apparent. Light impurities such as oxides and dirt rise to the surface, forming a thin layer of slag. This slag is carefully removed with specialized tools to ensure that it does not mix with the pure copper below. Heavier metals such as lead or iron sink to the bottom of the furnace and are then separated. An important factor in this process is controlling the atmosphere in the furnace. If the air contains too much oxygen, the copper can oxidize, forming a layer of copper oxide that reduces the quality of the final product. Therefore, many factories use inert gases such as argon to create the perfect smelting environment, keeping the copper in its purest state. Once the copper is completely melted and impurities have been removed, the molten metal is poured into molds. The pouring of the molten copper must be done with extreme care to avoid creating air bubbles or impurities. Molds are usually made of cast iron or heat-resistant steel, which can withstand high temperatures and help the copper cool evenly without cracking or deforming. Advanced factories also apply heat recovery and energy reuse technology. Metal dust and exhaust gas recovery systems not only reduce waste but also protect the environment. Once cooled and solidified, the copper is removed from the mold and moved to the next step in the recycling process, refining. These copper ingots, although highly pure, still need to undergo electrolysis to completely remove any remaining impurities and reach near absolute purity. To achieve maximum purity, copper undergoes an electrolytic refining process. In this process, raw copper is used as the anode, while pure copper is used as the cathode. When an electric current is passed through, copper ions move from the anode to the cathode, leaving behind impurities such as iron, nickel, and lead. After refining, the copper reaches a purity of up to 99.99%, ready for the process of creating new copper wire. The copper is reheated to make it more pliable and easier to shape. To increase the ductility and reduce brittleness of copper wires, they are annealed by heating them in a furnace at a moderate temperature and then cooling them slowly. This process helps the copper wire achieve the perfect balance between hardness and ductility. After the copper wire has reached the desired size and mechanical properties, it will be coated with an insulating resin to protect it from oxidation and ensure safety when transmitting electricity. The finished copper wires are rolled into large coils or cut into lengths as required. They are then packaged and shipped to factories or manufacturing facilities for use in electronic products, cables, or other industrial applications. The copper recycling process not only saves natural resources, but also reduces environmental pollution and energy consumption compared to mining virgin copper. Recycled copper still retains the physical and chemical properties of pure copper, ensuring optimal performance in technical applications. Thank you for watching the video. If you find it useful, please like, share, and subscribe to the channel. Press the notification bell so you don't miss the next videos. Now goodbye and see you again.